All right, let's zoom out from Earth and take our first real steps into the expanding cosmic horizon. Despite an infinite universe, experts like Brian Cox agree Earth is absolutely still our favorite planet. Why? Because out of 400 billion suns, it's literally the only known place where meaning actually exists. But, as Carl Sagan beautifully put it, we're finally wading out into that massive cosmic ocean. And hey, reusable rockets from SpaceX and Blue Origin are finally making access to Earth orbit incredibly cheap. This unlocks crazy things in near Earth orbit like dense satellite networks and making semiconductors in microgravity. Plus, asteroid mining offers limitless resources. We could literally move all heavy industry entirely off our beautiful planet. So, where to next in this explainer? Mars is our only real shot, since Venus and Mercury are deadly. Mars works beautifully. It has abundant subsurface water, plenty of iron for building, and decent enough gravity. Take the Hellas Basin, for example. It's a massive Martian crater 9 kilometers deep. Everest could easily hide inside. Because it's so incredibly deep, the atmospheric pressure is actually high enough for momentary liquid water to exist there. Now, switching gears to planetary physics, what actually decides if a planet stays geologically alive or just dies? It's all about the surface area to volume ratio. Tiny planets cool rapidly, just like a mouse loses heat faster than an elephant. So massive Jupiter generates heat by crushing metallic hydrogen, while a tiny planet like Mars goes completely geologically dead. But here's a wild mystery for you. If small planets die fast, why is tiny Pluto still geologically active? Pluto completely defies the rules. Scientists think it's actually fueled by this remarkably dense core of radioactive elements. Zooming way out to the Milky Way, Kepler data suggests there are 20 billion Earth-like planets out there. How do we spot life? We analyze starlight through atmospheres, looking for biosignatures like oxygen or even industrial CFCs. Right next door, we're literally sending robots to Mars right now to hunt for ancient surviving subsurface microbes. Remember, Earth was basically just slime for billions of years before a super recent, sudden explosion of complex life. It takes an astonishing 4 billion years just to evolve from a single cell into a full-blown civilization. Which leads to physicist Sean Carroll's haunting question: how many advanced civilizations actually exist in a typical galaxy? His answer? 0. If we're entirely alone, how will we choose to expand into that vast, dark unknown?